let's go back to this example. We're looking at magnification, but we can use an example that we've previously done. So in this example, we looked at a concave mirror and we placed the object inside the focal point, and we worked out where we would expect our image to be. In this case, it would be a virtual image, and the image would be 60 centimeters behind the mirror to a certain extent, right, in the mirror. So once I've got those values, I want to figure out what the magnification is here. And we know that if you place an object inside the focal distance, so this would be like a shaving mirror or a makeup mirror, you would expect a magnified image on the other side. So I want to know what the magnification is when you do this. Right, how do we do magnification? Well, we use this formula, m is equal to v over u. Now, for this example, we already have calculated v. There it is there, it's minus 60. And we've already calculated, or we were given u earlier in the question, so we have 15. So let's work out the magnification in this case is going to be minus 60 over 15. Now, this is a relatively simple one because we got 60 over 15, and you end up with a magnification of minus 4 in this case. Now just note that there are no units on this. Magnification has no units. Essentially what magnification tells you is the number of times bigger. It's a multiple. The number of times bigger or smaller an image is than the object. In this case, the image over here, this image, in reality would be 4 times bigger, would appear 4 times bigger than the object is in real life. So it would be 4 times. Now, what does the negative sign there mean? A lot of students get confused with this, and they would think that this means that the image is 4 times smaller because it's negative. This just shows you that the image is virtual. It's not possible, if you look at the maths behind this, it's not possible to have a negative u. It's not possible in this case. I usually tell students that negative for these means that whatever you're talking about is on the opposite side of the mirror. And it's not possible to put your object on the opposite side of the mirror and still get an image. It's kind of nonsense. So you can't have a negative u. Now you can have a negative or a positive v. So if this is always positive and you put a negative value in for v, well then that would mean that you would have a virtual image. Well then you have to end up with a negative value overall because it's a negative divided by a positive. If you have a real image, you have a positive v, a positive object or image distance. And again, you're over a positive, so positive divided by positive will give you positive. So if this value is positive here for magnification, it just means that you have a real image, that's all. What would a diminished image give you? Well, in a diminished image, if there was no magnification, so let's look separately. What does magnification look like? Well, if magnification is 1, if magnification equals 1 in the end, this means no magnification. So that means that the object and the image have the same, are the same size. So cases where you'd get this would be if you place an object at the center of curvature of a concave mirror, well then you'll get no magnification. If the object is 2 centimeters high, the image would be 2 centimeters high. It'll be inverted, but there'll be no magnification. If your magnification is greater than 1, if it's greater than 1, so any number greater than 1, that means that your image is magnified. So in other words, if we got a value of 3 or 4, well then that would just mean that the image was 3 or 4 times larger than the object to begin with. And if your magnification is less than 1, then it means that you have a diminished image. So in other words, we could imagine a magnification of 0.25, so a quarter. A magnification of 0.25 would mean that the object might be 4 centimeters high, well then the image would only be 1 centimeter high. It would only be a quarter as tall. And that's it.